Hello all and welcome to this session. This presentation focuses on CO-PO-PSO mapping aligned with the knowledge profile which we are calling as WK. It highlights how curriculum design ensures engineering excellence. The approach is aligned with the global accreditation standards. So let us proceed. Let us understand first of all philosophy of CO-PO-PSO mapping aligned with the WK, that is knowledge profile. Engineering education is moving from content delivery to competency based learning. Outcome based education ensures measurable student achievements. Structured mapping helps align curriculum with the global standards. So we need to understand these aspects carefully when we are approaching towards the outcome based education. So these are the foundations of outcomes based education. Outcomes based education basically have this approach to ensure that graduates should possess knowledge, skills, and attitude required for successful professional practice. OB philosophy also focuses on clearly defined and measurable learning outcomes. It ensures student-centric learning and skill development as well. Continuous assessment is integral part of OB philosophy, and that helps improve educational quality as well. Moving next, these are the pillars of outcome-based education. Program educational objectives define long-term achievements of graduates. POs, program outcomes, represent competencies at the time of graduation. PSOs are discipline specific. These are nothing but the program specific outcomes, and course outcomes are course level measurable outcomes. We all know these concepts very well now. Moving ahead, the Washington Accord and global mobility also we need to understand. Washington Accord ensures global recognition of engineering programs. It promotes international mobility of graduates, and accreditation ensures programs meet rigorous quality standards. Now let us highlight mapping the journey of WK Washington Knowledge Profile to POs and why this mapping matters. Number one, to justify the knowledge based behind each program outcome. Program outcomes describe what graduates should be able to do, but they do not explicitly state what knowledge enables those abilities. So PO is actually equal to skill or competency, and WK is equivalent to knowledge required to achieve that competency. Second, to show alignment with the international engineering standards. That means engineering program accredited under the Washington Accord must demonstrate that graduate attributes are supported by required knowledge profile. WK mapping helps to prove that the curriculum covers the required knowledge areas and the program outcomes are not arbitrary. Moving towards third, to ensure the curriculum completeness. WK mapping helps curriculum designers check whether all essential knowledge domains are covered or not. It helps to ensure balanced curriculum development as well. Fourth, to create traceability in outcome-based education. Outcome-based education ensures a traceable structure. This shows that curriculum is logically designed. Fifth, to support accreditation, NB or any international recognition, and this is one part of all of this mapping. During accreditation, evaluator may ask, does the curriculum cover all knowledge domain required for engineering practice? Are POs supported by proper academic knowledge? WK mapping provides this justification. So we should understand this justification properly. Now in sixth point, let us see this example. PO3 is design solutions, but design requires specific knowledge such as engineering science, materials, modeling, and sustainability. WK mapping shows that PO3 depends on WK and WK4 and WK5. Mapping program outcomes to the Washington Accord knowledge profile ensures that each outcome is supported by appropriate knowledge domains required for engineering practice and helps to demonstrate alignment of the curriculum with international accreditation standards. And that is important to understand as well. Let us move ahead. These are the knowledge and attitude profiles. WK1, Natural and Social Sciences. WK2, Mathematics and Data Analysis. WK3, Engineering Fundamentals. WK4, Discipline Knowledge. WK5, Design and Sustainability. WK6, Engineering Practice. WK7, Society and Environment. WK8, Research and Critical Thinking. WK9, Ethics and Inclusion. I'll elaborate each one of the WK in next slide. Next slide. First of all, let us understand the top-down conceptual hierarchy. Basically, the curriculum is designed using an outcome-based education framework aligned with the knowledge and attitude profile defined by Washington Accord. The knowledge profile WK1 to WK9 describes the foundational knowledge domain required for engineering practice. These knowledge domains support the graduate attributes which are articulated as program outcomes in the curriculum. Nextly, program specific outcomes. Each course defines course outcomes that contribute to attainment of POs and PSOs as well. Since each PO is supported by specific knowledge domain, that is WKs, the CO-PO-PSO articulation ensures the systematic attainment of the Washington Accord knowledge profile across the curriculum. WK mapping is done at program level, not at course level. So please remember this part very well. WK represents knowledge domain. CO represents course level learning. Mapping via PO ensures the structured knowledge distribution. The curriculum follow a top-down structure starting from WK. WK supports graduate attributes which further defined as POs. COs and course implement these outcomes at ground level. So curriculum involves all of these aspects. So let us remember this part very well. Moving ahead, let us now understand WK in depth. WK1, a systematic theory-based understanding for natural sciences applicable to discipline and awareness of relative social sciences. So as a curriculum, I can give you example here as physics and chemistry can be involved over here. WK2, conceptually based mathematics, numerical analysis, data analysis, statistics, and formal aspects of computer and information science to support detailed analysis and modeling applicable to discipline. As an example, I have included here the course mathematics. Third WK is a systematic theory-based formulation for engineering fundamentals required in the engineering discipline. So here comes the core engineering courses. WK4, engineering specialist knowledge that provides theoretical frameworks and bodies of knowledge for the accepted practice areas in the engineering discipline much is as forefront of the discipline. So I should say department core courses can be mapped under this. Fifth, fifth, knowledge, including efficient resource use, environmental impacts, whole life cost, reuse of resources, net zero carbon, similar concepts that supports engineering design and operations in practice area. So all design courses can be mapped under this. WK6, knowledge of engineering practice. It includes the technology in the practice areas of engineering discipline. Here we can involve the basic sciences as well. So laboratory work, all types of laboratory work we can involve over here. WK7, knowledge of role of engineering in society, identified issues in engineering practice in the discipline, such as professional responsibility of an engineer to public safety and sustainable development. So environmental studies related course can be mapped over here. WK8, engagement with selected knowledge in the current research literature of the discipline, awareness of the power of critical thinking, and critical approaches to evaluate emerging issues. So all types of projects can be mapped for this particular WK8. And the last one, WK9, ethics, inclusive behavior and conduct, knowledge of professional ethics. It may include individual and collaborative work like teamwork if they are working in the groups, responsibilities and norm of engineering practice. Awareness of the need of the diversity by reason of ethnicity, gender, age, physical ability, etc., with mutual understanding and respect and of inclusive attitudes. So all ethics related components can be mapped for this particular WK9. So these are the details or scope we can say for the Washington Accord knowledge and attitude profile. So how all of these components through all courses can be mapped to certain curriculum is explained in this particular last column. Washington Accord knowledge profile clearly supports program outcomes and curriculum as a whole. It ensures systematic curriculum development. WK also defines the knowledge foundation required for engineering practice. It includes mathematics, engineering fundamentals, design, and ethics. These knowledge domains support all program outcomes. WK mapping ensures that all knowledge domains are covered. It helps distribute learning across different courses and years. This ensures balanced and complete curriculum design. So let us move ahead if you understood it properly. Now explicit WK mapping for program outcomes is included in this slide. Let us try to understand. Now as we all know, PO1 to PO11 as per the new NBA version 4.0, we are having PO1 to PO11 instead of PO1 to PO12. So according to that, PO1, which is engineering knowledge, may be mapped to W1 to WK based on what scope your course is having. So either it is natural sciences like physics, chemistry, or social sciences. It also involves the social sciences courses as well. Mathematics, statistics, computational methods, engineering fundamentals, specified engineering knowledge as well falls into it. PO2, which is problem analysis, again we can map to W1 to WK. Again, it is limited to the scope of each course. PO3, which is design and development of solution, it can be mapped to WK5 as design knowledge with sustainability aspects are included here. PO4 investigation. It can be mapped to WK8 as per the guidelines. Research and critical thinking. This particular component can be involved here. PO5 modern tool usage. WK2 and WK6. Actually, for laboratory sessions, we do require kind of knowledge. So WK can be involved over here. Mathematics, statistics, computational methods, basically, engineering practice and technology. PO6, the engineer and the world. WK1, WK5, WK7. So it includes the domain knowledge as well, design knowledge with sustainability aspects, and role of engineers in society. PO7 is ethics. It can be mapped to WK9. Ethics and inclusive behavior. This scope is there. PO8 talks about individual and teamwork. WK9, again we can map PO8 to WK9, which is again involving the ethics and inclusive behavior. PO9 and PO10, which are communication and project management and finance. WKs are not mapped over here. So here I have not included the scope under Washington Accord Knowledge Profile. PO11, lifelong learning, which is mapped to WK8, which includes the research and critical thinking. So while showing the mapping of the POs with WK, for PO9 and PO10, WKs are not mapped. But as program outcomes 9 and 10 are mapped here, these are talking about the competencies, not about the knowledge domain specifically. So we can keep it blank, but we should justify it properly. Now let us understand the case study over here. So I have included here the case study for linear algebra and univariate calculus, which has two aspects, one as theory and one as laboratory. So for theory course, these are our course outcomes. So CO1, which is apply the concept of linear algebra for solving system of linear equations, linear dependence and independence, eigenvalues and eigenvectors. So we are mapping our CO1 to PO1, PO2 and PO11. Same is the mapping for CO2 as well. Again, we are mapping to PO1, PO2 and PO11. CO2 is evaluate indeterminate forms, Taylor's and Maclaurin's expansion using successive differentiation. CO3, which is formulate mathematical models for orthogonal trajectories, electrical circuits and one-dimensional heat flow solve it by using the ordinary differential equations. So we are again mapping this for PO1, PO2 and PO11. CO4, which is solve higher order linear differential equations and apply to electrical circuits. We are mapping this for PO1, PO2 and PO11. So we are having theory course for 2 credits, which involves the number of sessions as 30. Now let me elaborate the LAUC laboratory course as well. CO1 of this laboratory course is to develop MATLAB program to solve matrices, calculus and ordinary differential equation problems. So dedicated sessions are 1 for PO1 and PO2 because the foundation of mathematical knowledge is required. Then PO5 is mapped, which is the modern tool usage PO. Then PO8 and PO11. So total 14 sessions are dedicated for the CO1. Then CO2, which is prepare a technical mini project report and deliver effective presentation. So it involves PO1, PO2, PO5, PO7, PO8 and PO11. So total 16 lectures are there, sessions are there, right? So this is our CO2 PO mapping. Now let us understand how that POs are mapped with the WKs. So first of all, for theory course, we will check out LUC theory course where we mapped PO1, PO2 and PO11. So let me elaborate the statement of PO1 which is not explained in earlier slide. PO1 is engineering knowledge. Apply knowledge of mathematics, natural sciences, computing, engineering fundamentals and engineering specialization as specified in WK1 and WK4 respectively to develop to the solution of complex engineering problem. But for our course, we are just mapping with WK2 and WK3. This relates to the mathematical and engineering fundamentals. They build analytical and problem solving abilities. So all of these components are not falling under WK1 and WK4. Our course is limited to WK2 and WK3 in that aspect. We also mapped with WK8. Right? Now let me read out first of all the statements for this PO2. PO2 is about problem analysis, identify, formulate, review research literature and analyze complex engineering problems, reaching substantiated conclusions with consideration for sustainable development. So I already explained why we mapped WK2 and WK3 for these two POs. So PO1 and PO2 we are mapping to WK2, WK3. PO11 is lifelong learning, recognize the need for and have the preparation and ability of number 1, independent and lifelong learning. Number 2, adaptability to new and emerging technologies. Number 3, critical thinking in broadcast the context of technological change. So we have mapped here with WK as a mathematics is working as a strong foundation for rational and critical thinking. We have mapped PO11 to WK8. Let us move ahead for laboratory course. Now for laboratory course, PO1, PO2, PO5, PO7 and PO8 and 11 we mapped. We'll go one by one. PO1, as it is about the engineering knowledge, we mapped WK as discussed earlier. And as here, we need the strong base fundamental knowledge of mathematics to further move in the technical computation what we are expecting in the laboratory session. PO2, which is about the problem analysis, we again map to WK. PO5, which is about the engineering tool usage to create, select and apply appropriate techniques, resources, modern engineering and IT tools, including the prediction and modeling recognition, their limitations to solve complex engineering problems. So guidelines are we can map WK and W6. So WK2 also we can map over here. I have not mapped here, and WK6 also we can map here. Lab courses emphasize WK6 and tool-based learning. As this lab course need foundation of mathematical concepts, so we mapped PO1 and PO2 with WK. This strengthen application-oriented competencies. PO7 is ethics. Apply ethical principles and commit professional ethics, human values, diversity and inclusion, adhere to rational and international laws. So suggested WK mapping is WK9. PO8 talks about individual and collaborative teamwork, function effectively as an individual and as a member or leader in diverse multidisciplinary terms. Again here WK9 we can map because it includes the individual and collaborative teamwork, which is again a component of WK9. PO11, lifelong learning, recognize the need for and have preparation and ability for number 1, independent and lifelong learning. Number 2, adaptability to new and emerging technologies. 3, critical thinking in the broadest context of technological change. So WKE 8 we can map here as per the guidelines. So uh, we all set our rubrics to our mini project properly with ethical behavior, teamwork, and that's why we mapped WK9 here. So I'm giving here the justification why PO7 and PO8 we mapped and why PO7 and PO8 can be mapped to WK9. Again, as this is a mathematics course, that builds a foundation of critical thinking and students are actually working on mini project as well. We mapped it for WK8 as I told you just. With the mapping of PO to WK, we got clarity about how our course build different competencies that are aligned with OB philosophy. So this mapping helps us to understand where we are actually. Coming to next slide, let us broadly understand the relationship between WK and POs. Program outcomes basically describe what graduates should able to do after completing the program. These are the abilities or competencies. Whereas knowledge profile WKs describe the type of knowledge required to perform those abilities. So basically, these are knowledge domains. So if we are defining the relationship, it should goes like that. WK enables POs, knowledge supports competencies. WK provide the knowledge foundation required to achieve POs. So we should understand this particular relationship in between them. So there is no equivalence, right? Instead, it is a many to many relationship. So if you are working on your course, if you are mapping your POs to WKs, in that case, you can definitely observe that any WK can be mapped to multiple POs and any PO can be mapped with multiple WKs. For example, WK2, suppose mathematics domain I am considering, supports PO1 and PO2. Similarly, if I am thinking about the PO3, which is a design related program outcome, requires WK4 and WK5. So please, after listening this particular presentation, work out for your course and check out what type of mapping you can establish between WK and PO. So I must highlight some key takeaways through this session. Number one, program outcomes are mapped to Washington Accord knowledge profile to identify the knowledge domains that support the attainment of each outcome. Number two, WKs are more fundamental while POs represent application of that knowledge. A simple analogy you can remember. Suppose WKs are ingredients. POs are each dish prepared in our platter. Similarly, we should understand these three aspects as well. Systematic mapping, COPO PSO mapping ensures curriculum alignment with Washington Accord standards and program objectives. Progressive development. Outcomes built systematically from fundamental knowledge in FY to complex problem solving in final year. So it is addressing the entire curriculum from first year to final year. Accreditation readiness. Comprehensive mapping documentation supports successful accreditation reviews and continuous quality improvement. COPO PSO mapping aligned with the knowledge profile ensures that engineering education is structured, measurable, and globally relevant, producing students or graduates with the strong knowledge foundation and practical competencies. Knowledge profile, that is WKs, build the foundation, program outcomes reflect competencies, and structured mapping ensures effective outcome based education. So here we end. I hope this presentation is useful to understand the mapping between WKs and POs. Thank you all of you.